Alright, now what I've done since the last recording is, I've really gone in and made some schematics of what we're trying to do here. Here's our flashlight LED circuit, and here's just a candle LED circuit. These are the various resistors that are coming off our two switches. You can see here, this line goes down here, and circuitously it goes through a relay to our battery, and the anode of the battery goes to the anode of the LEDs. And this right here is actually a specialty circuit that controls our our flashlight LEDs. But actually I decided to do this a little differently, so let me make a modification in this real quick. This is a program I've used for a long time. It's kind of a cheap program. They don't make it anymore, so you can't actually go out and buy it. It's actually made by Protel, called Circuit Maker, and it's a schematic capture, and there's also a circuit board program associated with it. It's cheesy, it's got a lot of bugs, but it's easy to use, easy to learn, and because of that I've just kind of stuck with it all these years, even though I do have other circuit board programs that are more expensive. But I think I paid like $600 or something like this for this package, but the fact of the matter is you can't buy it anymore, so this is like Circuit Maker 2000. If that tells you anything, there's not an upgrade. This was the last version they released. So again, it's certainly lacking a lot, but it's still been an okay program. Although I do hate its schematic capture. It's pretty awful. The circuit board program is a little better. That's why I've used it all these years. But let me go to switches here. Let's see. Yeah, switches. I want to go ahead and change that to a double pole switch from a single pole. Actually, let me delete this one first. Okay, piece of crap. I've actually roughly guessed at some of the resistor values in my little chart here, and oh, you've got to be kidding me. And like I said, these are the resistor values for high switch, and these are the ones for a low switch, although they're going to be different than this when I actually size it in practice. But this is still a ballpark figure. But I decided, I'm going to implement a push button switch in here, and that's kind of what you're seeing in the schematic. And the push button is actually going to, like I said, control our flashlight only LEDs. Remember, that's the outer ring of 3 LEDs we have on our light. You know, these 3 right here. But what I decided to do is put a high mode, so that's what this 150 ohm resistor is for. That's full blast, and then the 33K is the nighttime or sleep mode, you know, which is going to be, you know, 1/10 of a milliamp or less. So I mean, it's going to be really dim, but so you can sleep by. And I've decided to go ahead and retain my settings on my other flashlight here. So I'm pretty much trying to duplicate the same current, you know, as my little swivel top or pivot top flashlight or candle, which means it'll still have a low setting too, but this will be 1.5 times as bright as that. However, you know, that's actually a usable amount of light, believe it or not, even at, you know, even though that candle is on a per LED basis only running 0.4 milliamps, but it's still, what, you know, in my opinion, too bright to sleep by. So I'm trying to dial that way down, taking into account that there are 3 LEDs in this instead of 2. So, you know, I want to put at least a 33K resistor in there to try to dim it down quite a bit. But what I'm playing with is the idea of putting this relay and this power jack in it. And what that means is you can plug a power supply, any power supply, you know, wall pack that's a 2.1 millimeter jack, which is a common jack. You can plug into this anywhere from, you know, about 8 volts to 24 volts, and what it'll do is it'll turn this relay on, and when it does turn the relay on, that actually opens the circuit. So that means that the flashlight will not operate, but you can actually turn it on these switches, even though it won't light up. And then if you ever have a power failure, the power will be cut to your power supply, which will cut the power to the relay, which will actually turn the you know, which will actually turn the candle on automatically in the event of a power failure. But that's the only thing it does. I mean, these aren't rechargeable batteries or anything, so it won't do that. And I don't have it set up to light up the candle or anything, because I don't know who would want to actually use this as like a desk lamp. But the fact of the matter is that you know, we could do that, you know, especially if we had like a 12 volt power supply plugged in here, which might be nominal. But I'd have to put a regulator in it if I did that, so that'd be an extra little bit of work, and then we'd lose the ability to really, or at least complicate the idea of using this as an emergency light. So, and what I'm going to show you right now is, let me unhide the components that I brought in. I brought these in from another project. But this would be the switch, the push button switch right here. That's our power jack, and that's our relay. And as you can see, we're pretty tight on space, particularly when I got to put, you know, 8 or 9 resistors in here, and these are 8th watt resistors, but we are still packed on space. That's why I'm not convinced we're going to be able to do it. In fact, I've even taken the liberty taking this power jack and putting it, you know, actually allowing it to stick out a little bit through our housing, you know, just to try to gain some extra room in here. But even then, it's so tight. We can see behind this switch we're going to have to build a well for it, you know, because there's going to be force applied from a push button, you know, on the outside going this direction. So, you know, with the wells and stuff like that, we're going to have to build around this thing. We're not going to have a lot of room. So that's why I'm really reluctant to actually put some kind of power regulator in this and make this any more complicated. It's just a prototype. That could be done in a future version of the product, but, you know, for right now, I just don't really see using this thing as a desk lamp. But it is a neat idea to make it plug into a wall adapter, even though it's only using it to power that relay. But, you know, in the event of a power failure, you got an emergency light that'll automatically come on to whatever switch setting you set this to. So, you know, you're not just totally in the dark if the power all of a sudden goes out. So it's a nice little use. You know, you can always find the thing that way. And And like I said, that's why I don't like rechargeable batteries. And that's what sucks about rechargeable batteries too. If you had, you know, actual rechargeable batteries, now you could use, you know, the kind of rechargeable batteries that are, you know, the same form factors like AA's or whatnot on this. Although the voltage will be a little lower, they'll run dimmer. You know, if you use actual rechargeable batteries on this, that the kind that you can remove and put in your own charger, you can still do that. But again, I don't like power, you know, built-in rechargeable batteries, because once they run dead, if you're sitting there without power, guess what? You're stuck. You can't replace them. You can't recharge them. So, you know, you're just kind of screwed. This way, you know, you can have extra batteries on hand, or go down to the store and buy batteries if you can, or whatnot, in a power outage, and if they're available, and you know, then you're off to the races. You know, if you run out of batteries on one of these lights, so it's better to make, you know, to use just regular alkaline batteries, you know, so you can swap them out if they go, you know, die on you eventually. But at any rate, you know, I'm still not sure if we're going to have enough room to incorporate this function or not. I would really like that built into it, but this relay is a little large, and it's the only relay that I actually have on hand, so, you know, without ordering parts. But I'm sure I could probably find a bit smaller of a relay than this, but again, you know, I'd have to place a parts order, and I don't know if I want to do that or not. But, you know, I guess I could if I had to, but I'll have to look into that and consider it if I can't find enough space for, you know, for this here. Oh, damn it. Oh. Yeah, I just don't think this thing's going to fit in here no matter what I do. Because like I said, you know, I've got to, here, let me also change some layers around too. I've added a couple of, you know, separated the electronics out into 2 different layers. But yeah, I don't think we're going to be able to fit all this in here. Here, let me get rid of this top. But I don't think we're going to be able to fit all this in here, you know, with 8 or 9 resistors plus, let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 9 to be determined. You know, I just kind of doubt that we're going to be able to fit all those in there, and it's not really all that practical. I mean, I could move some of these resistors to the upper LED board, maybe, but again, since I'm making these circuit boards myself and everything, and they're single-sided, it kind of limits how complex I can make these circuits. So, you know, as a matter of practice, I mean, it's just a headache to get too carried away with them. So I'm trying to keep everything simple. But yeah, I kind of don't think I'm going to be able to, you know, put these resistors in here and everything. I mean, because, you know, once I get down to actually doing the circuit board layout, I mean, it's, you know, I'm stuck with a pretty primitive situation, so it's just, you know, it's going to be hard to fit these sorts of things in here. So, you know, chances are I'm going to have to discard this, either that or create a separate circuit board layer, and I don't know if I want to do that, you know. You know, create an actual 3rd circuit board, you know, which I don't know if I want to get that carried away or not. I mean, I could actually choose to not mount the relay on the circuit board and actually just stick it in there somewhere else, so it's not actually interfering or taking up circuit board real estate. That's also a possibility. But yeah, I don't know. That's hard to say. Now these switches are not in their final position yet. And since this is going to be the outer rim of the housing, you know, right here, that's about where they need to be, actually. Let's see, because we're going to have a drape. Well, we're not going to be able to do that. Yeah, this is going to be a tough one. Go a little more in, because we're going to have about a 1/16 of an inch or so gap there. So yeah, it's actually going to have to go in a little bit, which is going to put a tighter constraint on our space. I have to take it into at least something like this. So yeah, it's going to be even more crowded in there. So if I am going to incorporate this relay idea, I've either got to go to a different relay or or mount this relay off board. You know, in other words, it can't be on the circuit board. I can just solder some wires to it. You know, again, it's a prototype, so it's no big deal. Because I mean, I can get a smaller relay that's about half that size, but probably, but I'd have to order it. And even then, I still may not have enough room, you know, for all the resistors and everything, plus the traces and everything else we need to do. It becomes a bit of a wild card. But it is possible for me to make a little well below the circuit board, you know, 1/4 of an inch or so clearance, and like I said, just attach some lead wires to, you know, because I only need a lead wire on this pin and this pin, because this is the coil pins, and then this one and this one, I believe, because that's normally closed, I think. So I just need 4 wires coming off and just hooking to the circuit board somewhere, and you know, I could probably get away with doing that and just keep it off the circuit board completely, and then I gain my real estate back for resistors and so forth. So, you know, again, those are some of the practical constraints you run into. That's why, again, drawing your components and stuff like that, all your fixed components you got to start with. That's probably what I'll do, because that's a very practical solution to this problem. Again, for this case, I wouldn't want to go into production on something like that, but I mean, you know, still for just what we're doing here, you know, that makes some sense. And like I said, I really can't move those resistors up to the main board on top, at least not very easily, because I'd end up with a whole bunch of wires running up through there, and you know, so that can get to be a bit of a mess. I mean, it's doable, but I mean, it just gets to be a bit of a mess. I'd rather just deal with 4 short wires going to a relay, I think, than dealing with a bunch of long wires, you know, coming from somewhere else. You know, I could actually locate the relay in this thing, because again, it prints from the bottom up, right? So, I mean, I could actually put a little relay well in here, you know, to actually hold this thing. Just use a hot glue gun or something like that to glue it in place, and then have the wires coming off the bottom of that, and I can actually pretty deeply seat it up in there, because otherwise this thing's basically hollow. It's a waste of space, because otherwise, you know, let's see, this is probably going to have to be upside down if we do this. Yeah, otherwise, let's see, let me get these things roughly aligned with each other. Well, you know, because that's basically how much depth. You know, all these components, by the way, are upside down, including the resistor, because if I mount things like this, again, it's a single-sided board we're going to make, so it's going to be full side up, so solder joints are going to be on this side. So at any rate, if I put the relay in here somewhere, you know, it would have to be upside down from its current position, but I'd have to put it in here somewhere well below our components. It'd have to be at least that deep, but that would work, though. However, you know, it might actually be easier to mount this relay up in here in a deep well, because, you know, it could actually mount, you know, I'd 3D print a well around it, but it actually mount up there quite a ways, so that'd give me some wire slack anyway. I could take advantage of that and just have these wires come out here, and I solder them. You know, these 4 lead wires come off this thing, and I solder them to the circuit board before I assemble these 2 halves, because I'm going to have to, you know, solder other wires coming from these the LED board up above, you know, to this as well anyway. So, you know, that may be the best approach, because basically these LED boards are all going to be, you know, there's going to be 3 wires coming from the LED board, the top board with the LEDs on it. So one for the flashlight LEDs, one for the, you know, one for the flashlight LEDs right here, one for the candle LEDs, and then there'll be a common, you know, in this case an anode, but that can be reversed if necessary. But the point is that you know, there'll be 3 wires coming from up here, and then I'll have, you know, which again, I got ample space to stuff extra wire up in here, and then I could have some wires coming from this relay too. There's a possibility, although I can't print an overhead or top on that well very easily. May or may not be able to bridge it, and like I said, it's still pretty tall, however you want to do it, so any kind of well would have to come out, you know, around this and kind of go this way, or divide this thing in half or something. But I still say a hot melt glue gun can actually secure that, even if it's just a divider wall in it, and leave us plenty of room for slack, you know. So again, that's a strong possibility. I'm going to really seriously consider that, because again, it wouldn't be that big of a deal to secure that up in there. Just be dealing with, like I said, 4 wires. So I may consider doing that. But in any event, you know, this well, I'm probably going to make 2 versions of it, just because I'm still not completely decided. So I'm probably going to make one that, you know, this part will go ahead and print a wall in it to support the relay. If I if I can get it to meld, then I may not, you know, given how complex this is, I may not be able to weld something like that in there because of the, you know, it's already a very complex part as it is. You know, we're lucky to be able to do Boolean operations on it, if you recall. But again, I may try it and see, you know, what happens. Which I guess I could, you know, try right now. Let me hide that ring. Let me hide electron. Well, actually, I don't want to do that. I'll go ahead and stick the relay out here for the time being. So, like I said, we're going to do this. Let me make absolutely sure, because I actually got the measurements out of this on from a data sheet. Instead of taking empirical measurements, let me, you know, I do have that relay sitting here right in front of me, so let me make sure the widths are the same. Yeah, 390, so that's right. Let me kind of center this, and I'm going to want to rotate this actually, because I don't want it to, well, I guess it doesn't matter. I guess it could be above our power switch. It's not really a problem. You know, because again, our power jack is going to be pointed down, so it's going to be pointed away from this, so these aren't going to really interfere with each other. See how much clearance we got here. 45 mil or so. Put a little bit of slack in there. Mount this. I don't want to mount it to the top because it may have wires coming from various places and so forth. But I want to mount it high enough to where we can, you know, get that relay in there quite a ways. And it does have to come exactly to the bottom. And incrementally save and actually did it. Go figure. Anyway, so that'll give us a, like I said, a place where we can mount a relay, and again, you know, it can go up and down in this channel wherever we need it. So, you know, to provide us some clearance, and there's still quite a bit of room to stuff wire, you know, both underneath this and so forth. So, you know, so there'll have to be a little bit of excess so I can actually, you know, when the things are in, you know, split in half, it's pretty hard soldering stuff. you know, you got to kind of bend them at an angle, you know, at a 90-degree angle to each other to, you know, keep the lead wires short, but at the same time, you know, have them long enough to where you can, you know, solder things together. So you can't put an excessive amount of wire slack in, but you can put enough. But, you know, what I do is I pre-solder the wires, leads onto the relay terminals that I'm interested in, and just kind of stick it up in there and hot glue gun melt it, you know, because I could certainly, you know, apply some glue around on the top, you know, just kind of drip it in on the top here, and then maybe, you know, a couple in the little dabs in the corner here. And that'd be enough to hold the thing in for this prototype. So, oh. But at any rate, that kind of solves that little problem, so that's groovy. Yeah. Anyway,